We're going to talk about infinite geometric series now. An infinite geometric series, first of all, you know it's infinite because it has an infinity sign, and it's referring only specifically to convergent geometric series. A convergent is the same as in the exponential chapter if I said something was decay. So let's just take a look at a very basic series. If I start with 1 and I say r is a half, the next term I would add would be a half. Then if I used r again, I would add a fourth, then an eighth, and as you can see, these are getting smaller by a factor of 2, and they're getting smaller quite quickly. And if I kept going like this, eventually I would add 1 over infinity, which is actually defined as 0. And so this is a little bit ahead of our game here. This is actually a pre-calculus concept called a limit. But what it does is it shows us that the original formula we had, Sn is equal to a1, 1 minus r to the n over 1 minus r, is actually, look, if my r value is convergent, it's going to eventually add 0. This part at infinity, right, this part goes to 0, leaving me with 1 over 1 minus r times a1, or a1 over 1 minus r. So it's the same formula. As n goes to infinity, Rn will go to 0, meaning the sum will eventually add 0. Please remember the hidden parentheses on the R and on the top and bottom. All right, so now we're going to look at examples, and they're going to be just like the previous ones we did, but with an infinity sign. So notice this is the same kind of deal. It says rewrite the following using sigma notation. So we're still going to say sigma right here. And we're going to say n equals 1 because we have 12, and we're just going to put an infinity. Why are we doing that? Because it says dot, 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 or goes to infinity. And remember that inside of here, we're just going to use the formula for an, which for geometric would be a1 r to the n minus 1. So I'm just going to put a1 in there. And then I'm going to find r, and then have it go to n minus 1. And so r is found, right? R is found by simply doing a2 divided by a1. And so r would be 9 over 12, or 3/4. And so that's done. Just like any geometric problem, writing the formula for geometric is very straightforward and easy because you don't have to reduce it. So now that I see this infinity, that means I'm going to use this formula instead, which is a reduced version of the other formula. And so what I'm going to do is I'm going to put a1 in. Please remember that a1 means put 1 into here. It's very important, okay? So 3/4 to the 0 is 1. 1 times 12 is 12. You have to check to make sure that a1 is actually what you think it is. A little more obvious because I showed it to you here. And then 1 minus r, and r is 3/4. And of course, you can type that into a calculator if you want, but this one is kind of neat because unlike the other one, which gets really overwhelming, this one can actually be done by hand. So you would get 12 divided by 1 minus 3/4. That's really 4/4 minus 3/4, or 1/4. And then you would reciprocate the 1/4. And so this will eventually add up to 48. 12 divided by 1/4 is really 12 times 4. So that's kind of interesting that as I go to infinity, the problems actually get easier. It's almost like an oxymoron, which is kind of cool and a relief, right? It's a relief. So here are two that are actually in sigma notation. And if I were to do this problem, now that I know the secret, it says infinity. So I'm going to say S infinity is equal to a1 over 1 minus r. Please remember that the secret to an A or a B plus in this chapter is to write down the formulas. So what I'm going to do there is just say S infinity is a 1. Please put a 1 here and make sure it actually is what you think. So I put a 1. This will go to 0, giving me 2. But keep in mind, this is really important to watch this. If I were to actually get rid of this part, which they do sometimes, especially on a standardized test, and I put 1 in there, that's now going to be 4/5 times 2. A1 would be 8/5. So you have to plug the 1 in, which is very important when it's actually 0. And then down here, we just have 1 minus r. R cannot be messed around with. So r is going to be 4/5. Okay, that really can't be changed. And so you could do this one by hand as well. This would be S infinity is equal to 2. 1 minus 4/5 is 1/5. So that would come out to 10. So you can type those in, and maybe if it was complicated, I will too. But when it's really simple like that, again, I mean, I'll just type it in for you. So if I were to look at this problem, what I would do is I would just say, okay, it'd be 2 divided by 1 minus 4/5. But again, it sure isn't a bad idea to try to do some of it, with your brain. It's a muscle. You want to make sure you let it do some work. So this one, again, is still infinity. The reason it's infinity is because it's right there. So S infinity is going to be A1 over 1 minus R. I was writing it in a different format, but there we go. That's the format we're using. And so A1 in this is not A1, right? A1 is A0. So that's what you have to watch out for. It's actually less difficult than any sigma problem you've ever seen, but you do have to watch out for when this says 0, because now the formula is A0 over 1 minus R. So how do I find A0? What I do is I come over here and I just do the work, right? 6 times 1/3 to the 0 plus 2 is really 6. 1/3 to the second power. If I want to type that in Desmos, I can. I would just get 6 times a ninth, or 6/9, which is equal to 2/3. All right, so I can put that in right there. It's 2/3. And then on the bottom, I just have 1 minus R, and that's going to be 1 minus 1/3. And you might already be able to tell if this comes out to 1, because you have 2/3 over 2/3. If you want to type this into Desmos, feel free to. So that would be 2/3, and then of course divided by 1 minus 1/3, and so this comes out to 1. Okay, so just be aware that these problems are not actually as hard as you think they should be, because they're infinite and they're convergent and all that stuff. They actually just want you to recognize that it's infinite and it uses a modified version of the formula. So the worst thing they could possibly do is give you like a word problem like this. And again, the secret is to write down the formula. And because of the fact they say it's infinite, they sort of give it away. So let's read it now that we see that. Carefully, the question about the series and find the indicated values. Find A1 for the geometric series, given that S infinity is 12 and R is 1/3. So we're going to write down the formula. S infinity is equal to A1 over 1 minus R, and we're going to plug stuff in. It tells us that S infinity is 12. It tells us that A1 is what we want, and also tells us that R is 1/3. So now what I'm going to do is just solve this equation for A1. So I would get 12 is equal to A1 over 1 minus 1/3, which is 2/3. And what I'm about to show you here sometimes throws students off. So I'm going to do like a little review back in algebra. So imagine you're back in algebra and someone says, how do you solve 12 is equal to x over 3? Well, you would say to me, oh, you multiply by 3. And so that's how you would solve that, because they cancel out. Well, guess what? You can do the same thing here, and you would multiply by 2/3. Now, some students will say, well, don't I reciprocate that? You would if it was in front, but it is on the bottom. And the way you cancel division is to multiply by the same thing. So it's kind of interesting how that works. It does throw some students off. But again, look here. To get rid of 3, I multiply by 3. To get rid of 2/3, I multiply by 2/3. And that will give me A1 is 12 times 2/3, which is 8. So even, honestly, if you see infinity, you should think, easy problem, the formula is smaller.